Welcome. Today we'll analyze a force function that increases to its maximum value and understand how to interpret this type of graph. Let's start by looking at a typical force versus time graph where the force increases to a maximum value. Here we have force on the vertical axis measured in newtons and time on the horizontal axis measured in seconds. The force in this example starts at zero and increases gradually at first, then more rapidly before leveling off at its maximum value. This type of curve is common in many physical situations. In the initial region of the graph, the force increases gradually. This might represent, for example, the force applied when stretching a spring or the thrust of a rocket engine during startup. The middle section shows a steeper increase in force. Here, the rate of change of force with respect to time is at its greatest. This represents the period where the force is changing most rapidly. Finally, the force approaches its maximum value. Notice how the curve levels off asymptotically. This maximum value represents the largest force that can be achieved in the system. In this case, the maximum force is 8 newtons. Let's consider a real-world example. When stretching a spring, the force initially increases quickly, but as the spring approaches its elastic limit, the rate of increase in force slows down until it reaches its maximum value. Beyond this point, the spring would become permanently deformed. Understanding how force changes over time and recognizing maximum values is crucial in physics and engineering. It helps us design safer structures, more efficient machines, and better understand the physical world around us.